Eh?
bothata ne ile eng?
Ke na se ya be se ke mona ya sokodisa.
Ah, okay. No problem then. So you can still see my screen, I get.
Yebo.
Okay, no problem. So that was the first question, a potential difference. It's a definition. Let's not waste too much time on it. Number 1B.
Oh.
Let me clear the screen. Number 1B. It says write down an equation which defines potential difference in terms of work. Yeah? Okay. So do you have your formula sheet with you? Okay. So the question asks you to write down an equation that defines potential difference in terms of work done and charge.
Ya ke ka
Okay, no problem. How can check on your formula sheet? You have in this equation. Yeah, W is equals to VI delta T. Yeah. Remember, how do you know where does this equation comes from? You know the definition of power, ne?
Yeah.
Power. It's capital letter P. It is the rate at which work is done. Work is done. Ne? So even in mechanics it's the same thing. So that means its power is equals to work divided by delta T, because it's the rate at which work is done. Ne? But we also know from our electricity definition that power is equals to voltage times current. Ne? So from this equation, where we see power, we put our voltage times current, more than power. Then is equals to W delta T. Then you cross multiply that delta T, you get W is equals to VI delta T. This is how this equation came about. Yeah? Fine. Now going back to answer the question, they want us to show the equation that defines potential difference in a form of work and charge. So again, that equation again, but not exactly as it is. Then delta T. So potential difference is there. Ne? That means at least one of these things is achieved. Now we need Q again as a charge. So from our definitions, what is current? Current is the rate of flow of charge, or this is the flow of charges. When electrons move, they create what is called an electrical current, the flow of charge from point A to point B. That is current. Yes. So current is the rate of flow of charge, of which it's what? That is Q over T. Ne? So when we see I, we replace with this here. Then it says write down the equation which defines potential, yeah, which is equals to W is equals to, let me see something. Okay, I see something. Okay, this is the correct way of showing it. That is Q, our Q charge. Then delta T, this delta T times this delta T, so delta T over squared. Ne? This is Q. Then there's another method again. Hide. Then there's another method again. There's another method again. Also the formula sheet again. Okay, it's fine. From your formula sheet, this is work. And from your formula sheet again, you have this equation here. Work is equals to VQ. I think I won. So now,
yes, I won.
Yeah, where we see work, we can replace with this. So VQ is equals to VI delta T. Now the problem will be these two things will cancel each other. Then Rasala got this. Then when you divide by T, you have a definition of current, which is equals to Q over T. That is why I chose to do it in that form. Before.
Yes.
Why won't I get? Yeah. So, but either way, no kaira this way lihona. You just shoot voltage in a form of a charge. And in the form of what? Yeah, in a form of, in terms of work done in charge. So this one will be wrong. The previous one was right because you cancel our work done now. So never mind this one. Ne? I thought it would derive again. Mark eliminate the work. So the previous one was the correct one. Why do you validate the hands of Maya every day? Bam fitlhela mo tshwantse ke thabeng bona tshwantse ke thabeng. Okay, let's move on. Define EMF. So when according to what do you think for EMF ke in?
EMF is the maximum energy. The maximum energy that the battery can supply a cooling charge.
What again?
The maximum energy that the battery can supply a cooling charge.
Okay. Well, I would say you are correct. That is EMF. No? And then what is EMF in full again?
Right. What do you mean?
What is EMF in full? I'm getting EMF. It's an abbreviation.
Yeah.
So this is EMF, ne? And you are right when you say that is the maximum amount of energy that a battery can supply. That is correct, ne? Okay. Remember last time I told you EMF or voltage is the reason why electrons move. Yeah, so when we check this thing, electro means charges, electrons. Motive means movement, force. So this is the force that moves electrons. EMF, this is the force that will move your electrons. Electromotive force. So for current to exist, for current to move in a second, EMF is required. Without a voltage, current cannot do anything. Electrons cannot move. So there's no way you can have current and not have voltage. I hope it makes sense.
Alright. Yeah, it is.
Jesus. But if it gets up, bona my control panel is exactly chief. Okay, Aaron, I get to repeat. And I'm not going to fix after class. And those looking at this. Okay, so yeah, bro. Okay, let me speed up then. What is the unit of potential difference in EMF? That is volts, ne? Okay. The question says what is okay, number 2. Okay, so
I think number 2. Number 3, but then I was not sure. And then carry on number 6.
Okay, number 6, sharp. Okay, it's fine. Number 6. They say calculate the equivalent total resistance between point A and point B in each of the following cases. Okay, number A. Last week I drew a table for you, and lucky for you, this week I are recording the class, so you can go back to the class and check what we are doing. Last week for you, I showed you something about parallel and series. Hopefully, I'm correct.
This week.
Yeah, this week. Series, ne? So I said in parallel, when you calculate the resistors, if there are 2, you're gonna have Rp is equals to R1 multiplied by R2 over R1 plus R2. So this method will be easier for you when they are many. To avoid troubles, just do 1 over Rp is equals to 1 over R1 plus 1 over R2 plus 1 over Rn, where n it shows already the maximum number of resistors. Then in series, when you want R series, you have R1 plus R2, then y add R3. So this is how you add your resistors in series. Then I also summarized, I told you already, in parallel, V total is equals to V1, which is equals to V2. But here, V total is equals to V1 plus V2 plus Vn. So when we get to Ri, current, I1 or I total is equals to I1 plus I2 plus Im. Then I total is equals to I1, which is equals to I2. So check out here. So if you can check your current, they are equal in series, and then when it comes to parallel, that is the voltage that is equal. Then when you come to series, you add your voltages, and then when you come to parallel, what you add is your currents. So get vice versa. Why born and get. So sharp. Let us answer that question. I just wanted to make a summary for you. Clear? Okay. The question says calculate the equivalent total resistance. Ne? So your 6A looks like this. You have this is how I'm gonna show my resistors for now, and this is also a signature for, or a symbol for resistors. Ne? Okay, this is 2 ohms if I see properly. This is your 3 ohm, and this is your 5 ohm. Ne? Okay, what kind of, this is your point A, this is your point B. What kind of connection is this? So you have identified it as a series connection. Fine. So since this is a series connection, according to the formula that I gave you, the table that I gave you, in series, what do? You add them. Ne? So this is 2 plus 3 plus 5, of which it will give you 10 ohms. So that is the total resistance of this series connection. Ne? Fine. If we go to your number B, they give you the same resistance but in parallel. Ne? So in number B you have this, and you have this. So this is your point A, this is your point B, this is your 2, your 3, your 5. Okay, so if you are to identify this configuration, is it a parallel or a series?
Parallel.
So it's a parallel, né? So according to the table that we provided, or I provided, 1 over RP is equals to 1 over R1, of which is 2, plus 1 over R2, of which is 1 over 3, plus 1 over R3, of which is 1 over 5. Nah? So what is the common multiple between all three? I think the common multiple between 5 and 3, it's 15. But 15 is not a multiple of 2, ne? So the common multiple of them will be 3, 0. Ne? So when you multiply here, you multiply like this, then automatically 15. When you multiply here, auto multiply like this, then automatically 10. When you multiply that one, auto multiply like this one, then automatically 6. Of which is equals to 25 plus 6. This is 31 over 30. Then you have to invert it. I'm gonna erase. Why won't I get rid of the
for sure. Because many people do the exam as a base, then the rest of this month. I don't remember many
Okay, your network I experience difficulties of hearing you. But I think we could have like something okay, say that again.
Yeah, like like had to do regulatory status that is one of the things, but then more now that we continue.
Okay. Yeah, I agree, Mola. We were at RP's cost to here 31 over 30. But what you are looking for is not 1 over this, it's RP. so you invert it. So even this one you interchange it, it will be 30 over 31. Then you find the value of this. Definitely it will be 0.
Yeah.
It will be 0, a certain number. Eh? Okay. So now number C. So let's do number C. Your number C, it's clear canvas.
Like 3 is 3 canvas. Are they parallel?
Obutaka number C.
Yeah.
Okay. Let me draw the circuit first. Ne? Okay. Your circuit is like this. Then we have a resistor. Then we have a resistor mono. Then we also have a resistor here. So we have 2, we have 3, we have 5. Okay, this is how your circuit is, and this is B, this is A. Okay, your question is, are they in series or parallel? Ne?
Yes.
Okay, these two are in parallel. Ne? So the total amount of the parallel connection after doing the RP, that RP is in series with this one. Why what? So how do you deal with this? This is how you deal with these two are in series, ne? So you can confront it as RS is equals to R1 plus R2, where R2 is equals to your RP. Ne? So what are you saying?
3 5. Parallel.
Yes, yes. 3 5 in parallel. Okay, as you said. So how we can mona? Also rewrite as R1 plus let's say this is your 2, this is your 3, R2 your R3. So plus R2 R3 divided by R2 plus R3. Then you substitute values. This is 2 plus 3 times 5. This is 3 multiplied by 5. This is 3 plus 5. So 15 over 11 plus 2, it's how much?
37 over 11.
It's how much? 3,36, ne? Is this what you got? Am I still with you? Let me check.
Hey, the same.
Okay, yeah, no, I guess I would do before.
And 3 times 5 over 3.
Okay, it's a mistake. This is 8. So
It's 3,8. Yeah.
okay, correction. This is 8, 8. Okay. Yeah, thanks for paying attention. Okay, so you saw when they combined your series and when they combine your parallel, how you do them. Ne? You first notice that this it's a resistor, then you combine these two to make them one resistor. From there, once this one becomes one resistor, it will become like this. Then it will be this plus this. Why one? Okay.
Then I have the number 11.
Now you want number 11. Okay. Number 11. So number 11 says calculate the unknown values in each of the following. Okay. Calculate values of the unknown. Let me draw the circuit. So we have your battery of 12 volts. We have a battery of a 12 volts. Just to brush on something. Remember, when this is alone like this, it's called a cell, né? And when they are together like this, it's a battery.
No. Yes. I didn't know.
Yeah, so I just wanted to brush it off. Yeah, so that because these are the tiny things that you forget, then you get it. For multiple choice, what are the difference? Then you don't know how to answer it. One. So we are given this as 12 volts. Then the longer side is your positive, the shorter side is your negative. Then you have your ammeter here. What is ammeter used to read? Out of between your resistance, your voltage, and your current. What it reads what?
What's the current?
Yeah, it's current in amperes. So how can you an example of what current is measured in amperes? Then also it reads current in amperes, the ammeter. Okay. Then we have a resistor mona, and we also have a voltmeter V1. And this instrument, voltmeter V1, it's used to measure your voltage, potential difference. Yeah. Then we have another resistor here and a voltmeter on top of it. This is V2. And then we are going to have artery and voltmeter V3. This is your V3. Okay, so the question says, let me see. Okay, but if you for this voltmeter V2, it reads 6 volts. Ne? Then they give us the value of this resistance as 10 ohms, and the current here is 0.5 amperes. And what else? This is the only information given. Ne? So let us, and they say calculate the values of the unknowns. Ne? So our unknown mona is V1. Another unknown, this is resistor R2. So R2 is also unknown. This is R3. R3 is also unknown. Even V3 it's unknown. So it's R2, R3, V1 and V3. So we need 4 values. How do we get that? So as you can see, this is a series connection. Do not mind these guys. These guys are only here to measure the voltage that's passing. Man, that's in between the two terminals. A voltage doesn't move, ne? The only thing that moves is a current. So this V2 is here just to measure the potential difference between this point A and this point B. So it's not a this thing as a operator, as this thing. It is an operator, but it's not a component of the circuit. What I want to get, just this element. Okay. So now, when we want to get voltage, we know V1 is equals to I times R. That is any voltage, it's equals to I times R. So the current that's passing through all, it's 0.5 multiplied by what? 10. Oh no. 10 we're gonna erase, yes. Multiplied by 10. So this will give us 5 volts. That is 5 volts here. This is now 5.
So you use the current area 0.58.
Okay.
Is it like for the whole section?
Yeah, it's for the whole circuit. Key point, they are connected in series. Meaning hore this guy 0.5 autofeta on all resistors like this. That is the key point. Okay. Then that's the value of our V1. What else? We need R2. Ne? R2. R is equals to what? V over I. Ne? We want V on R2. V on R2 is what? Is this guy, 6 over I. I said I applies to all resistors. So 6 divided by 0.5, I think it should be 12 in ohms. So we have R2. So this guy is, we got him, this guy we got him. Now we want R3 and V3. Yeah? So here we don't know anything. But what we know is that there is 0.5 amperes passing through. Yeah? And what we know too, because we do not have any internal resistance of the circuit, is that the voltage here, the voltage on V3 is equals to 12. This 12 ne, minus 5 minus 6, of which is equals to 1 volt. So here we got V3 is equals to 1 volt. Ne? Now, since we have V3 and we have current, we can get R3. So okay, let me write this because I'm really going to get this one. R3 is equals to V3 divided by I. V3 is 1 and I is 0.5. Yeah. So 1 divided by half, you are going to get 2. This is 2, and then we are looking for R3, so it's ohms. wayibona ngere. So this is how you can.
Oh yeah, this is the reason why Omana City 5B6B from 12 is because the a series connection voltage device.
Come again.
The reason why Omana City 12 that again doesn't matter Omana City 5B 6B from 12B is because all a series connection voltage device.
Yes, that is true. That is true. In series connection, the resistors are voltage dividers. So the total sum of our voltage must add up to 12. And the only voltage you do not have is 1. So you subtract everything from the total, you get the only one that you do not have. Right? So yeah, that is true. Since Okupetore refetseka 9, so it's 3 minutes to 9 p.m. I don't know, we can do another circuit maybe for the next 10 minutes or 15 minutes, or you can